I'll record this session. So we are going to do a system design of a gaming leaderboard. So do any of you guys have any idea on what a gaming leaderboard is? Hello.
Gaming leaderboard as in like the those betting sites.
No, no. So see, a gaming leaderboard is basically, you play various games like PUBG and all that games you play,
Okay,
right?
so videos like
No, no. At the
leaderboards.
at the end of your game, you get a score, right? And when you see
Yes,
that score across all the players across the globe, you're getting that score, right? So if so, that's very distributed in nature. There's a lot of architecture going there, right? So if you think about it, a small company that's just building a small mobile game, they want to give that kind of experience to their users, but they don't want to invest in all the infra to build all that, right? So just like for authentication, like we discussed, we have these solutions like Auth0 or Stitch or something like that, where you integrate the
correct. Yeah,
API and it's done, right? So for gaming leaderboard also, there's maybe some kind of solution that is provided to these companies where there are just APIs, and they backfeed the user data into that API, and then they get back responses. Okay, so whenever an interviewer talks asks you these kind of questions, right? So we did high level design of more complicated components like Amazon or like Hotstar or things like that, right? There's a lot of moving parts, but when you look into this kind of small SaaS solutions that you're supposed to build, and this question came in Angel One interview, right? If you see Leadboard, it also came in, I think, Mintra interview, third, second round, Angel One hiring manager round, right? So when you're given this kind of small SaaS solution, like build a real-time gaming leaderboard, build a Google small file storage uploading system, right? These are or build a notification service, right? So the expectation is different. The expectation is you are going to write the whole thing, right? You will basically have the APIs. You will try writing the database structure. So it's not just HLD anymore. It's HLD plus a bit of LLD also, right? So we're going to start with it, right? So we'll start by sketching out some of the basic functional and non-functional requirements, and then we are going to start first. The first thing when you're writing this kind of SaaS kind of apps, right, unlike things like Amazon, is that you don't know what all the requirements are. So try to get that from the interviewer, right? So let's open up Canva. Mm, and even for like version control system, or whatever we have done till now, right? So I hope my screen is visible to you guys, right?
yes, yeah.
Okay. Gaming leaderboard system. So what a leaderboard is, first, like I mentioned, a leaderboard is basically used for so you have these third party gaming apps, right? Let's just say this is a gaming app, right? Sorry, let's say games, right? So this is a game, let's say online Jenga, okay? Online Uno someone's playing, online dice someone's playing, right? Where is it? Online dice roll or Ludo King or something like that someone's playing, right? Online snake and ladder, right? So these are my games, right? So these are games being played. Okay, I'll take it then. I'll take this here, right? So these are games being played, and what these games are doing. So whenever these games are let's say when they are completed, right? So what happens when the games are completed, they send a they show you a leaderboard. They show you that what is your rank, right? What is the score that you have gotten and all that, right? And it also compares you across all the users across different regions. So what my leaderboard system is basically going to be a SaaS, right? It's going to be a SaaS solution. Our leaderboard always identify the requirements whenever you are asked to build a SaaS solution, right? Always identify that, this is what I'm aiming to build. This is the kind of problem that I'm trying to solve, right? uh, our leaderboard system is going to be a SaaS solution. And now let's talk about what this SaaS is going to do. So, what is the problem that it's going to solve, right? So, this should be clear in your mind. Obviously, you're not going to, describe all of that in the interview. But let's say that we have various games that will send data to this to my solution, right? To my software, to my SaaS, right? To my SaaS, right? And now the game will now I will generate a leaderboard for each game based on my data, right? And the games can ask information about this data that I generate, right, at any time, right? So our leaderboard system is basically going to be a SaaS system. We have various games which are going to send, like, when you're playing this game, once you've completed this game, it's going to send this data to my to my processing. Let's just name it something for the time being. I'm going to name it uh, leaderboard data processing service, right? Data processing service. It's going to process all the data. We have various games which are going to send out the data. So arrow. Okay, so these games are sending their data down to this data processing service. I'm going to copy paste. Okay. Okay, so I copy pasted this. This is going to the data processing service. And in terms of let's say post request, there could be multiple kinds of request if you think about it, right? um, so one of the requests I can think about is post, game data, um, the metadata. Let's think about the metadata together, right? And one of the, get can also be there. So for now, there's various scopes of the system. One of the ways could be like, what are the types of games that you play, right? Do you remember, like, Ninja, right? Thailand Ninja, and others, they were playing PUBG, right? And there was this leaderboard that kind of showed live that, okay, this many kills are happening, right? That, I'm having this many kills at this given point of time. That's one kind of leaderboard where the data is going from your game to your application at given at, like, certain points of time whenever a kill is happening, or maybe 1 second, 2 second down the line. Usually kills are not updated like that. So it's like after a period of time that data is sent, right? And the leaderboard updates itself. Other thing is at the end of the game, like, something like Ludo King or something, that does that at the end of the game, that data goes down to the server, right? So this is your intuition. You have played these games, you should be able to come up with this based on, your own understanding, right? Now I want you guys to tell me what this post game data can contain based on, whatever discussions we have had. What metadata will this pass?
Like the real-time scores.
Okay. First is ID, right? ID of the user ID,
Yes, ID.
right? ID of the user. I can. There could be cookies and everything that's passed, and then yes, game, maybe score, right? Game ID. Game ID is going to probably recognize that game, current score of the user. There could be other metadata also. You can think of it, right? Game ID could be which game is being played in specific in the system, right? Or you can it could be other things also, right? But in general, it's you're basically just sending the data from this side here to here, right? And you can think of an authentication that's happening in this SaaS, right? A smart way that I can think of that I will authenticate, right? Is let's say, so I have my backend in the game, right? So what I can think of is a machine to machine integration. Okay, there's something machine to machine integration. So there's not going to be a Google OAuth authentication or something like that, right? For SaaS solutions, it's usually machine to machine authentication, which means that just like IAM, we establish trust between the data processing service and this, right? So this is not a user's device. This is not a user's device. This is a server that's sending this request. So all the requests from your mobile, right, that goes into the game server. The game server is going to call this SaaS application. So try to understand where I'm putting a putting a breakpoint there, right? Just like in Book My Show, we made a breakpoint, right, in between the third party, where the local movie theater system and the Book My Show server, right? We put a breakpoint there that they are communicating like SaaS communicates, right? So here also we are going to basically, that's going to be a breakpoint, and there is going to be machine to machine authentication, right? So anyone has any doubts up to this point that we discussed? Okay, no doubts. So do you guys know what machine to machine integration is? Paras, do you know?
No, not much idea about like machine to machine authentication.
So there's three kinds of two or three kinds of authentication. Okay, one is the user authentication. You have this Google OAuth authentication, right, where you're
Yeah.
passing, and this is a very important thing. People will ask you in interviews a lot,
Okay.
right? So just pay attention, everyone. So see, you have auth 0. If you see any authentication solution, there are multiple kinds of authentication. If you look at APIs or something, here you should see SSO types of authentication. Here they will show you what are the different types of authentication. Read this doc a bit because it's very popular. So you have different types of auth. See, there are different authentication, but in general, I'll tell you, okay, just read it a bit more. But there are two kinds of authentication. One is the user authentication. The user can authenticate through multiple devices, through IDs, right? So you have Google authentication, where you're putting your email ID, you're putting your password, and you're authenticating using your email. For Google, you're using a Google OAuth token that is generated, you're authenticating with that, right? So from different devices you can authenticate. Machine to machine integration is an IP address kind of based authentication, where you are basically establishing trust, right? So this IP address recognizes this device, right? So in a system, you establish that level of trust between a system, between this system and that system, that okay, if the request is coming from this IP address, or it's tagged like that, right? Or maybe you pass in something, so it's going to authenticate it in, and it will understand that where this request is coming from, right? So that is machine to machine authentication. It's a yeah, hi Shweta. Hello. You raised a hand, right?
Yeah, sorry, I was speaking on mute.
Okay.
So, this machine to machine authentication is being authenticated by a authorization server.
Yeah, definitely. So, authorization. Yeah. So, authentication and authorization are not like you don't have separate servers a lot of times. If you think of it, right? So, what is authentication and what is authorization? Authorization is basically stating that authentication is basically stating if this user has the access, right? And authorization, I mean, authentication identifies this user to a specific ID, right? That this is the user. And authorization
Correct.
says that if this user can access this web page, right?
Mm,
So authentication and authorization are pretty different if you think like that, right? Authentication, the purpose of authentication is identifying users, right? So there are multiple ways you can identify a user, right? And this question gets asked a lot, right? Let's just say you have a URL shortener service, right? A URL shortener service. Now, how do you identify different users that are logged in your URL shortener service, right? Because when you think of it, you have a URL shortener service, right? Here you cannot put login, signups, and all that stuff, right? So what is the data that is available to you, that through which you can uniquely identify a user? One is you can identify him through an IP address, that this is the IP address that's hitting my short URL, so this IP address makes this user unique, right? So through that you can identify a user, but then you have these other tricky use cases where there's an office Wi-Fi, right, that's masking all the IP addresses, right? I hope this is something you guys know. But that's masking all the IP addresses. So if that's masking all the IP addresses, right, then how are you going to know, right? So then you come up with other solutions. You come up with a solution where it's first visiting that IP. I'm stealthily just putting a cookie on the on here, right? So sometimes you will see that you will open up cookies. After opening a short URL, you will see there's a cookie from the open in app will put a cookie there, and using that cookie, the next time you log in, he will see that okay, this guy has visited 2 times, right? They've stored that in their Redis tree. So that's authentication in general. It's identifying that you are visiting from your device, you're visiting somewhere. It's identified that okay, Shweta Kumari has visited this page. She has visited it twice, right? Because you are just a hit rate. How does the server know, right? So that's authentication. That can be done in multiple ways. The major reason why machine-to-machine integration is so much used is because you have the sensitive passwords and stuff, right? Whenever you're doing M2M, like whenever in an AWS account, right? Let's say there's something like an S3 bucket, right? And you are accessing that S3 bucket through a password and you're giving it to someone, right? That employee is quitting the company, right? He's angry. What he does is he puts it on the public key or internet, and everyone starts using that as their personal cache, right? So there's a lot of damage that can happen to the organization when this kind of things happen. That's why you have machine to machine integration, which means that this S3 bucket can only be accessed through this other solution. So there's this trust that is established through IAM, and no other device can so there's no password in all, right? There's no password at all, right? That's how the communication happens. Okay, so this is a bit of an important concept. So I went off topic and explained because it comes a lot, right? So but again, it's just basic auth, right? So there's games being played and stuff like that. They are sending the data to the data processing service, right? And then this data processing service is doing a couple of things, right? What I can think of it's doing is it's generating a leaderboard, right? It's generating a leaderboard. It's saving. It can save the game data. Maybe the leaderboard is not being generated on the go, right? It totally depends on what solutions you are trying to provide to your through your SaaS, right? So if you guys are able to think of something else, definitely pitch in. um, I'm just thinking on the go, right? What else is coming to your minds when you are looking at this?
Metrics and analytics.
Yeah, metrics and analytics, right? Because that's important, because that can detect fraud as well, right? If some zero rank user is suddenly climbing the leaderboard too fast, you can flag that. And now whenever we have this metrics and analytics, there's a good thing that this data processing service can do. It can backfeed into this game and tell them that something suspicious is going on, right? So that brings us to another microservice that can feed from data from this data processing service, right? Which is basically going to be the analytics service, right? So this analytics service can hit this game service whenever it feels that some kind of fraud and anything is happening, right? Can notify. It can do a lot of things. Can notify about fraud, right? Fraud. It can also send back user data. right? So whatever general metrics and stuff is happening, it can send back the data. And then for this data processing service also, I can think of like a database, right? You will be storing all the data in Postgres, right? So this Postgres table database might be used for storing the saving the game data, right? And what else I can think of is what does the leaderboard service do? It saves the game and it generates the game and then saving the game data. Um, game data. Okay. So and your leaderboard gets generated. People are the leaderboard updates on the fly, right? So and that leaderboard changes, like whatever changes that are happening to the game has to propagate to all the users. Okay, so one primary thing we should discuss always is that that should be discussed at beginning of every system design is what should we use in cap theorem. Should we prioritize consistency, availability? And obviously when you look at the kind of system, right? So if this was a stock market trading system, then I would prioritize consistency. But since it's a gaming system, I'm going to prioritize availability, right? Because it's not necessary that everyone gets the updated data. So whenever some data processing service, whenever something is updated, it goes to this Postgres, right? And then I can think of something like, and think of a leaderboard generation service. Board generation service that basically generates this leaderboard from this data, right? So it reads from this data and generates the leaderboard. Okay, so we are also going to look into certain popular videos and try to understand how this thing, how certain databases have like Redis has a solution that caters specifically to this kind of leaderboard solutions, right? um so okay, but if this is generating the leaderboard and the leaderboard is getting updated on the fly, right? Uh, how do we shard leaderboards, right? Like let's say something like Ludo King has a. Again, sharding is not a big problem. What we can think of, we can shard by games played and stuff like that, right? Um, okay, so this is the basic architecture of the leaderboard service, right? What I can think of next is that the major question that an interviewer will ask you in this leaderboard service is how do we how are we storing the leaderboard data, how are we generating the leaderboard data super fast, right? So it's a trivial question if you look at it, right? For leaderboard service you should know this. There's something known as a Redis sorted set. Do you guys know this? How many of you know this? Just raise your hand. Redis sorted set. No one knows this. Just put your hand up. Anyone knows this? Okay, that is a bit concerning. I should know this. Okay, and so because why am I saying this is important is if you see, right, uh, if you see that there are these there are a lot of videos on this, right? Because when you talk about a leaderboard service, right, there are these solutions that have been built for leaderboard service for generating that leaderboard on the go, right? So I'm going to teach about Redis, but there are other solutions that exist like Rockset and all. The major reason why this is important is because imagine you have millions of records, right? Millions of records, and you want to generate a like leaderboard like of the top 10 records at any given point of time, right? If we go back to our data structure and algorithm fundamentals, right? What would we do for this kind of thing? We would have a let's say we'll have a double linked list, right? We'll have like a double linked list. That's how you generate a leaderboard, right? On the fly, right? Why are you guys so silent? Okay, we have a double linked list and we'll have a hash map, right? We'll have a hash map, and let's say within that double linked list, right, we will have basically have like this is let's say value customer one, right, his code with his code, right, his code, and then that's this will be a sorted linked list, right, and then when we add customer two with his code, just give me a minute, right, and we are basically just going to add it on the basis of with his so like basically it happens like this, right, that this is a double linked list that is created in a sorted order, and now if you want to, if let's say one customer gets like one person gets a higher score, so what you do is you first go to the hash map, you find that person's id, you say this person, this is getting a higher score, so you are going to put this back, do like this, and then you are again going to do it like this, right, you're basically going to change the order until the list is sorted again, and then at any point of time you have this leaderboard, right, that is built. There are binary search solutions also, I think, but I think this is a general solution, right, so what this database is, right, what Redis sorted set and what Rockset and all they do is it's basically a similar implementation, right, you cannot create you cannot create a double link list and you hash map hash tables and stuff like that on the server like that, right, that's for DSA, but this is where your DSA stuff comes in, right, so Rockset does that, or what a Redis sorted set is, I'll tell you guys. mm, it's basically like a set of like this, right, so for let's say for your, I'm gonna just copy this and make it clearer. Is any one of you guys having any issue with understanding whatever I'm saying so far? Just raise your hand, or just say that I'm not able to understand. So this is a game. This is, let's say, Ludo King, right? Ludo King. So this is the Ludo King leaderboard, and this is the person's name, and this is his code, right? So as this entire leaderboard is built using ZAD, right? So you're doing ZAD this, ZAD that, right? 10 node M, node M1, node M2, right? And then at any given point of time, at the you will see that you will see after ZAD you are going to take this, right, you are going to like do this research scores 0 to -1, so you want the top 10 listings, you will get -1 means give me all the listings, you can do 0 to 10, you will get the top 10 listings. So this set is always in sorted order. That's basically what a Redis sorted set is. It is very very important because without knowing this you might not be able to do this problem, right, not just this problem, there are a lot of problems if you go back and think that you can solve with the knowledge of a sorted set or something like that, right? So is this portion also clear to you guys, or any questions? Okay, yeah, Mrityunjay.
How we are like storing it in the DB actually.
how you're storing the how you're
Like
storing the data in the database? Okay,
yeah,
you mean the what do I say, the game data, is that what you mean, right?
yeah, yeah.
So
Like are we storing it like for the individual player
yeah.
or for like the entire game in the single table or something?
Yeah. So basically, the way that you think of it is that your data that is stored in the database or Postgres is basically mostly for analytics purposes. The main thing is going to happen in the Redis sorted set, right? So the data that goes through your data, like ingestion. For ingestion, maybe we use Kafka, right? So from ingestion, it goes to the server. That data is directly going to be put into Redis, right? You are going to run this ZAD operations on that data, right, and you're going to add that into the sorted set. So at any point of time you want to find the leaderboard, it will find the top 10 leaderboard. Now what is the metadata that you have, right? What is the metadata? So when you are doing this, your ID, right? So you need the info of the user, you need all the other info. For that you are going to use your Postgres database, right? But for generating the leaderboard on the go, right, this Redis solution is enough, right?
Okay.
I mean, think yourself, right? Is it enough or is it not enough, right? What else can you think of? Okay.
Uh,
Ask questions, like ask more questions. Try to see that, if I'm saying something wrong, if there is some piece to the puzzle that I'm missing. Like I'm saying this Postgres is going to collect all the data, right? It's basically going to be there for like storing the user information, right? That this is the user, he has logged in, this is his data, right? So there could be events that this user is throwing. You can think of it as a CQRS architecture also, right? This system is going to throw out events to here, which are going to be stored in Postgres, and then based on these events we are creating views. But except here, what I'm doing is, since Redis has given me such a beautiful solution for just managing, which is used literally by all kinds of gaming leaderboard services. So I'm going to separately have, I'm basically just going to separately push this data from here to here, right? And whenever I want the top leaderboard information, I'm going to get it from Redis. I'm going to go to my Postgres and I'm going to get all the metadata information, and that is what I'm going to return back to my game, right? Makes sense, right?
yeah.
Yeah, yeah, sir.
Okay, any more question? Yeah, sure.
So at what point of time we are pushing the data to Postgres? Because if we are getting it from Redis, then definitely it has to be a cache miss, and then we'll get it from DB, and then we can revert back again. But what time we are putting it to DB?
We are using Redis in a very different way here than the traditional Redis use cases, right? So when you think of it, the traditional Redis use case is a cache. You put the latest data in the cache, right? But here Redis is being used as a sorted set, right? We are basically using the Redis for finding the top 10 data, right? So if there's a cache miss, then the entire leaderboard needs to be rebuilt based on the data from Postgres. Okay, so
Mm-hmm.
um, what happens is, whenever a data is coming in, right? When you think of the data, it's basically like an event that has happened in the system, right? So you are just putting that in Postgres, and you are also pushing that into Redis using this ZAT command, right? You're doing this
Okay.
ZAT for updating that user scores, right? The issue in a gaming leaderboard implementation, whenever you get a cache miss, you're not supposed to get a cache miss ever. Like, if you get it, you have to rebuild your entire system. Then what you do is, you go to Postgres, you pick up all the user data, you rebuild it, and you push it into Redis, right? Shouldn't be a long operation. Actually, it will be a long operation, but you slowly push it into Redis, and the leaderboard is basically built on the fly at any point of time, right? Whenever you want the leaderboard, you have it in like one time.
Okay.
Yeah, I mean, not like I want you guys to think, right? It's not like I am not like memorizing this, right? I mean, I read about sorted sets, but that's part of basic learning. You should know about sorted sets or whatever else I'm talking about, right? So it's my implementation that I just thought of in the mix. So if I'm thinking of this here, you should also be able to think, right? So just think of it, right? Any questions that are coming to your mind, right?
So Ramit, these game events, what you are talking about, this will be getting consumed on a very frequent basis.
Definitely, that's why we have Kafka here, right? So when you talk about it, right, game events, right? Let's say we have a game like Ludo game, right? There's millions of people playing it, and they are all dumping events. At the end of the game, these events are getting collected, right? So, like I said, from the capturing principles, availability is, what is the more important thing here. So, what I can think of is that, we'll have a server that runs, and the way we used to deal with low latency system, we have a server which is called a producer that runs whenever this comes in, and we have Kafka. This is where we are going to use the message queuing abilities of Kafka. Assume this is Kafka, okay? Assume this is Kafka. We have a producer that runs, and which whose basic responsibility is whenever it gets it, it's going to put the a basic message into Kafka, and then we have consumers that will slowly run, and at its given pace, and it's going to slowly build out the leaderboard by putting data into Redis and stuff like that, right?
Okay.
Okay, so anything else that any of you guys want to discuss on this?
Ramit, is there not going to be any issue with the memory? Like, let's say there are a million users, and I'm assuming that a user would be seeing like 10 ranks, top 10, and also like seeing his rank. So,
Yeah.
like, let's say his rank is like in millions. So, like, how it will be calculated?
True, that is a very interesting question. That's why, for solving this question, right? A knowledge of Redis sorted set is very important. If you see here, this is a deriv range, right? It's a one-line answer to your question, right? You see there,
Yeah,
you're just putting your score. So you're saying for a user, yeah. So like I said, it's basically going to give a range for a user. I think there are keys where, you can basically get the user ID also. So this leaderboard is for the top 10 rank, but I think you can search by this name also. It's going to return the ID in O1 time, right? And for this also, basically, so your DSA info implementation is important. So just think of it, right? If this was a DSA problem, how would you solve it? There's a hash map where the user and his ID is there, and at any given point of time, you have this sorted set, right? So at any point of time, what if you want a user score, if it's millions, you go to the hash map, you find this customer too, you get his score, and you return it back, right? That's how you'll do a DSA solution for this.
yeah, that's fine. But like, are we storing like all of the users in the Redis?
Yeah, all the
Okay,
users.
like
So
not only top 10.
yeah, that's how a sorted set works. You never know when a user is going to move up, right? That's why, so this sorted set, right, this implementation is specifically for the real time gaming leaderboard. If you see Rockset as a database, right, they are a competitor to Redis. They started with this implementation. They started with this, implementation, because they targeted that my customers are going to be people. So they first built this, managed solution for this real time gaming leaderboards. But this is a challenging problem, right? Because like in DSA, you can think of it like this is basically like a, I think, a mid hard problem, right, in deep code, right? How you're going to design this leaderboard. So that's how they are basically solving that, right? So we are doing these tricks.
Okay.
uh, I'm still reading on that, right? So I've not read on it very well, but that's how you build like a leaderboard system, right? You think from the basics, right? APIs designs, you can think of, right? Basically, there are certain contracts that's a question that could be asked. So there are certain contracts that get exposed, right? This data processing service is going to expose. Post could be the game data, and with the ID, and the get would be the maybe the game's top 10 leaderboards. Get would be probably with his ID, it could send him his position as well, right? And then again, I mean, that's all there is, I think, for the leaderboard. So it's like we spent 45 minutes doing this discussion, right? So that's the usual length of a system design discussion, right? So we had enough topics to discuss, right? And I think that should cover up your interview, right? So any other questions that you guys might have regarding this? Nothing, right? Okay, let's then do some general advice and stuff, right? Like, let's sync up, see how we are doing.